So now I'm going to explain the neuromuscular junction and then the excitation coupling reaction. His first objective, this is Fang's third lecture, his first objective is understanding the concept of a motor unit. That motor unit is, you have a somatic motor neuron, and then that's going to have an axon, and that axon can bridge out and it can innervate different muscle fibers. So the actual motor unit is that axon and the muscle fiber that it innervates. That's what a motor unit is. It's motor neuron with the muscle fibers that it innervates. So the second objective is understanding the signal transmission through this neuromuscular junction. So the neuromuscular junction itself is that axon terminal with the what is called the motor end plate. So you're going to have a presynaptic portion and then a postsynaptic portion. So this postsynaptic portion is called the motor end plate. But that neuromuscular junction includes the pre, the post, and this cleft. That whole thing is called the neuron muscular junction. So this is muscle and that's the neuron. So now we're gonna explain the signal transmission through all of this to this muscle and the T-tubule. So first, in this axon, you're gonna have a stimuli, and then that's gonna create an action potential through that axon. So once we come down, we're gonna have calcium connect to its calcium gated channel, and that's gonna stimulate this axon terminal to release its acetylcholine from these vesicles that it has. That acetylcholine is then gonna bind to its receptor, and that is going to allow calcium and sodium to enter the cell. Once sodium enters the cell, potassium gets out of the cell. It's like a body. So once potassium gets out of the cell, this cell membrane, this muscle cell membrane, is now depolarized. So once this is now depolarized, it's going to activate this sodium gated gate, and that's gonna also release sodium to try and get this system back under works. But what that's gonna activate is an action potential again. So we have an action potential here to get the stimuli from the axon itself. Now we need to get this action potential down into the muscle. So once we depolarize this membrane, that's going to activate this sodium gated channel to send that action potential down. So once we send that action potential down, now remember we have a T-tubule, which is what I explained in the past video. Remember, the function of this T-tubule is to allow that action potential to go deep into the muscle cell. So this is our T-tubule itself. Once this action potential reaches deep into the T-tubule, we're going to have what are called the Rye receptors and the dye receptors. So this action potential is going to activate a dye receptor, which is also a calcium channel, but right now it has nothing to do with calcium for some reason. But this dye receptor is going to connect to Rye. Once it connects to Rye is then going to take the calcium from this SR, the sarcoplasmic reticulum. It's going to take that calcium and it's going to shoot it out and send it into that muscle fiber. What this calcium is going to do is going to, like I explained in the last video, is going to attach to that troponin to move the tropomyosin out of the way and then create the whole cross-bridge cycle. But this is how it all starts. So that's the second and third objectives, all in that cycle. But once it gets to the troponin and then the tropomyosin and it does that cycle, once that is done and it does the power shift and then the power stroke and then ITP connects and now we're relaxing the muscle, that calcium is going to come back to its SR, and then we need to stop this. Because this acetylcholine activating, we're activating a contraction. Now we need to relax. So now we have this acetylcholinesterase, and that is going to degrade the acetylcholine in this cleft so that we can relax and we can stop sending action potentials all over the place. Then the last objective is to understand what a slow or a fast twitch is. So it's basically in the name. A slow twitch is going to take longer to recover, and then a fast twitch is going to take faster to recover. But the slow twitch is also called the type 1 or the red fibers, and that's because they have a high concentration of iron and blood supply that contains the myoglobin, and that makes it red. And then the white one does not have this blood supply therefore it doesn't have much myoglobin, makes it white in appearance. And then the slow ones, since they're slow, you can imagine that they're gonna have a smaller motor unit controlling it, and then fast is gonna have a larger motor unit controlling it. So this slow one, since it's aerobic, it's gonna need that oxygen. So when you're doing long endurance sports that you do need that oxygen to continue throughout the sport, that's when you're gonna use a lot of these slow twitch muscle fibers, because those are things for distance running, marathon running, and things like that. But these fast, explosive sports that you need to, basketball, weightlifting, hockey, those sports, you're gonna use more of these white, fast fibers. And then what are some key points? The slow have a lot of mitochondria to get you through that long endurance sport, while this fast one doesn't have that much. And then this fast one is going to have a lot of high myosin ATPase activity, and that's to get you through that high explosive sport, since we don't have a lot of oxygen.